value. And this one's a little bit vocabulary heavy, so sit tight, relax, get your note out, and get going. Ready? Notice you'll see where the notes are, the unified notes or video slash notes, and the unified practice. You've got two there to pay attention to. So, without further ado, let's get this going. It's been a little bit since we've done this, but we can do it. Okay, so a definition, a relation is is a set of ordered pairs. That's a mathematical definition. A relation just meaning a way to relate quantities of values. That's it. We have a special name. We've got a few other special names here. We've got another special name called function. A function is a specific kind of relation where each input is assigned exactly one output. Okay, so inputs typically in math, we've been talking about x's and y's. So if we have an x of 3, when you put it into a function or an equation, right, for us, you do some calculations to it and it spits out one number, say 5. Okay? If for each value of x that happens where you get only one specific number, then we give it a special name called a function. There are situations where you can put an x value in and it'll crank out more than one value. And in that case, that equation or that function, we would consider that to not be a function. Okay? Okay. In math, and especially for our purposes, we have a special name called domain. Domain is called the input values, or so the numbers that you can put into the equation. We have a fancy word, range, which are the values that come out of the calculation after you put the input of the domain in the equation or the rule or the function. All right. Now we're going to use those words over and 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 over again today. So kind of like having a little machine, right? You have this function machine which does something on the inside. You take a number or a value and you put it in to the machine, and out comes another number. In particular, if it's a function, we have a very specific number that comes out. If it is not a function, we could have two different numbers get spit out when we don't really understand that. We don't really know. Okay? So here we go. We need to determine whether these are functions. Remember, for each input, which would be on the left, this one is called mapping, by the way. For each input, there is one output. So now if we look at this, if we look at -2 right now has two different outputs. It's going to two different things. It is mapped to two different things. So we call this not a function. Okay? Part B, and 3 only goes to 1, 4 only goes to 1. So we would consider that to meet the function criteria, but not the -2. We did a quick mapping of like 1, 2, 3, and we went to like the numbers 5 and 6. 1 goes to 5, 2 goes to 5, and 3 goes to 6. That would be a function, because each one of the things on the left only goes to one thing on the right. Those are two different situations. One's not a function, one is a function. What would be considered, what's another example of something that would be considered not a function that has a similar type of setup? Maybe write that down right now. Check to see if you know what that is. Okay, so let's look about B. If our inputs on a graph are our x's, so are there only one x or one y for each x? If x is the input and y are the output, are there only one y for each x? Well, if I take a look at 7 and I draw a line down to where it is, it only hits at one point, only hits at one point, only hits at one point, only hits at one. So that means for each x, there's only, and this is just really steep, but it's the same scenario, only hits at one point for each one of those x's. This one we would consider, yes, a function. There's another test if we have a graph. It's called the vertical line test. If you draw a vertical line and it hits anywhere on the graph more than once, we would consider it not to be a function. Okay? Okay, let's continue. We're going to work a lot with these. We're going to have the same conversation a lot until we get very, very used to it. Okay, friends? So let's look at C. If the inputs are x only goes to one number. 3 only goes to one number. 5 only goes to one number. 7 only goes to one number. We would consider this a function. Okay? A corollary that would not be a function is if we have an x and a y, we had 1 goes to 3, 2 goes to 4, and we say 2 also goes to 5, and 3 goes to 6. 2 goes to two different things. This would not be a function, whereas the example we would give you is. Let's look at D. D. 2 goes to 1. Are there any more 2s? 2 also goes to negative 2. Since 2 goes to two different things, we would consider this not a function because the input of 2 goes to more than one output, not a function. Okay, let's take a look at some other components. Are these functions? 1 goes to a single value. There's no other 1 in the x column. Goes to a single number. All of these only go to a single number. 2 goes to a single number, 3 goes to a single number, 4, 5, they all go to one number. It's okay that 3, 4, and 5 go to the same number. The question is, the input of x, do they go to more than one number? The answer of that is no. This is yes, a function. Okay, let's look at B. Is this a function? X, this one's negative 4, negative 2. So the x coordinate of negative 4 goes to negative 2. This is negative 2, 1, and negative 2, 2. We have a scenario here where this is not a function because the point or the x value of negative 2 goes to two different values, namely 1, y being 1, and y being 2. The same thing is true for the 3. Like if I draw a vertical line here, the value of 3 goes to two different numbers. There's two ordered pairs at the x coordinate of 3. That means it is not a function. Okay. Is this a function? Now, there's another component we talked about. Is it a function? Input, output, domain, range. We have one-to-one, meaning one x value goes to one y value. We don't have the y values doubled up, and we don't have the x values doubled up. Okay, so is this a function? Function, the number 1 goes to the number 2, so that qualifies. And there's no other doubled up x's. There's no, like, there's not two 1s that go to two different, or 1 doesn't go to two different numbers, 5 doesn't go to two different numbers, 7, 8, they don't go to two different numbers. So this, we consider, yes, it's a function. Is it one-to-one? Meaning, for each one of these, are the outputs mapped to only one thing? We can draw a mapping of this. We can write down the x values in a bubble. We can write the y values in a bubble in numerical order too, because -1, 0, 2, 6, and we can map this. Do these guys only go to one of these guys? And both are not doubled up. So 1 to 2, good. 5 to 6, good. 7 to -1, good. 8 to 0, good. So this is, yes, it is one-to-one, meaning one x value goes to one y value and nothing more. Let's continue. Are these functions? Okay, so let's look at this. We have, are these functions, are they one-to-one? For A, we have a mapping where the inputs are on the left and the outputs are on the right. So for each one of those numbers on the left, do they go to just one number on the right? If that's true, we consider it a function. If that is not true, we can consider that to not be a function. So let's look at it. -2 is mapped to 5, that qualifies. 3 is mapped to 6, but 3 is also mapped to 7. That means it is not a function because 3 is not a function. And we say it's not a function because 3 is mapped to 6 and 7, not a function. 3 is mapped to 2 different items, not a function. If it's not a function, it cannot be one-to-one, meaning one x value goes to just one y value and vice versa. So let's look at B. Do each one of these x values on this graph match to one y value on the picture? Yes. It would also pass the vertical line test, and that's a representation of each one of the x's going to only one y if it crosses just at one spot. So this we would consider it a function. Are there more than, are the y's doubled up as well? Are the y values written twice for any x value? Or let me rephrase that. Are there more than one x value? No. Are there more than one y value that is mapped to an x value? Meaning, are just one x and y pair for each thing paired up once? In this case, the answer is yes. So yes, it is 1 to 1. All lines are going to be functions and 1 to 1. Okay. All right, let's look at 3. C. Do each of the x values only go to one y value? Now this is a relation that's written as ordered pairs. Okay. Sometimes I like to drop them as mappings to understand a little bit more about what's going on, but in this case, let's not do that. So is there more than one 3? Is 3 mapped to more than one number other than 5? No, it's just mapped to 1. So let's keep checking. Is 1 mapped to anything else other than 7? No. How about 4? No. -3 is mapped to 9, and it looks like -3 is mapped to 5. Since -3, it is not a function. Not a function. Why isn't it a function? Because -3 is mapped to 9 and 5. So therefore, it is not a function. Let's look at D. Is it a function? Is 1 mapped to 17? Yes. 1 is only mapped to one thing. The value 2, the input of 2 is only mapped to one thing. Input of 3 only mapped to one thing. Input of 4, input of 5, those are all only mapped to one thing. So that yes, it's a function. But is it one-to-one? No, it's not. Because both, it's not one-to-one because 17 is doubled up. Because both 1 and 2 map to 17. All right, let's do one more. We're not going to do these other bits of it. We're only going to do this last one. So Mrs. Thill is going cliff diving. The graph shows their height over time. Find the following. What's the domain? Domain, if you remember from the beginning of our conversation, domain are the x values. So in this case, we're going to say it's time in seconds being the domain. What is the range? It's the y. So this, in this case, it's height in feet. Okay, domain is our x's, range is our y's. In this case, it's time in seconds. Is it a function? For each second that she goes cliff diving, is there only one y value sent out? So if she goes cliff diving right here, at that second, there's only one value for each one of these x values I'm pointing out. Therefore, yes, it's a function. Is it one-to-one? Are the y values doubled up? Well, if I have this point right here, she's at that height, she's also at that height again a second time. That means for both like 1.9 seconds and like 0.25 seconds, she's at the same height, which would get doubled up. Therefore, it's not 1-to-1. Okay, now you do have an assignment to do after this, so if you need to rewatch the video, please do so before you work on that assignment. Okay, friends? All right, take care. Peace.